Cloud software and cloud services are ubiquitous these days. AWS is one variety, and Milovan will take us on a journey and explain the quirks and tricks of testing AWS solutions. Please, take it away.
Thank you. Okay. Thank you. Just let me present myself. So I'm Milovan. I'm coming from Serbia. As you can see, I'm 2 meters tall, but I'm not a basketball player or volleyball player or anything. I'm a software tester from Novi Sad. I work in one company called Execom. If you see, this is our emblem. And I worked there for the past 3 years, performing mostly functional testing of web-based application. And for the past year, I'm working on 2 parallel projects. One is based on AWS, which stands for Amazon Web Services. This is Amazon solution for cloud computing. The other one is on Azure, Microsoft solution. So basically, those are 2 biggest and largest providers of cloud computing in the world. And the idea and motive for this presentation came up 1 year ago when I started searching for tutorials regarding AWS, and I found some for developers, but I didn't find any for testers. So it is my chance to be pioneer at something, I guess, but I don't know nowadays are there articles regarding AWS and stuff like that. So let me just go to agenda so you can switch room if you don't like it, but I hope that you will stay. First of all, introduction, we already done that. Then I will explain some basic terms regarding cloud solution and overview of the services that we used on our project. Then I will show you example of AWS architecture, how you can monitor stuff on AWS, then how I wrote my test cases, some examples, then how we automate stuff on the AWS, then how we execute those tests, some words about performance testing, and conclusion in the end. So just to clarify some basic terms regarding cloud, we have some old architecture that is traditional, that is on-premise solutions. So basically we have our all resources like servers, databases, operating system on those servers, like virtual machines and stuff like that, security patches, and it's all hosted at our local company or somewhere where we can approach it. What is the difference between the cloud? Cloud says, okay, you don't have to take care about infrastructure, don't take care about servers and stuff like that. We will provide you whole infrastructure, which is really scalable and can handle a lot of load. Only you need to pay as you use it. So all the managing server stuff, you don't have to take care about it anymore. It is all on cloud providers. You just need to configure it correctly and, of course, pay for it as you use it. That scalability and paying stuff is very interesting. For example, Netflix, I think you heard for Netflix, it's very popular in Serbia, is hosted on Amazon. And basically, for example, when new season of very popular TV show gets out, a lot of people go to Netflix and load just rapidly increase, like 3 times, 4 times, 10 times, whatever. And then after that, it goes back on regular usage. And what happens on cloud? They provide resources for all that load. After that, they come back, and you don't have to have like infrastructure for all that big load. You have only to configure it properly on cloud, and that's all. So what is the idea of AWS is they want to satisfy the customer in every single way, and they developed a lot of services, like more than 100. And basically we used these like 7 months on our project, but you will get idea how it functions with those services. First service that I will explain is Lambda. Lambda enables us to run our code in the cloud, and we need to just upload zip file in one of the 5 supported languages like Java, C#, Node.js, Go. I don't know what Go is, but it's supported, Python, and that's all. What is interesting about my project is that we developed the application in C# and hosted it on AWS. And why is that interesting? Because Microsoft Azure solution native language is C#. So it's much more natural to have C# application running on Microsoft Azure. But our clients was very impressed by possibilities of AWS that they insist to have C# code running on AWS, and as you can see, it is supported. In the end, they were right. We did it in that way. So basically, you upload your code to Lambda, then Lambda function is created, and that code is executed every time when it is triggered. So basically, it can be triggered. It can be triggered in a lot of ways. Please. It can be triggered in a lot of ways. We did it in 3 ways. Basically, when some file is uploaded to the cloud, that code in Lambda is triggered and it is executed. The second way is by HTTP request. And the third is some other AWS service can trigger your Lambda. Basically, some other Lambda can trigger your Lambda to execute. Of course, we need to have a database. DynamoDB is NoSQL fully managed database, which is really fast and can really scale up and scale down depending on storage you need. Also, API Gateway. API Gateway is a service that enables us to expose our API endpoint, basically, so all the client's application can consume cloud if they hit that URL. Also, API Gateway enables us to secure those. I will explain it later how. S3 bucket basically stands for simple storage service. And that way we can host a big data on our cloud, like files, like documents, pictures, and so on. It is a really nice overview. We have S3 bucket, and then we have folders, subfolders, files in it. So we can upload whatever we want to our cloud. Cognito. Cognito is one very interesting service because there is a lot of questions about security on the cloud. And what was the greatest disadvantage of cloud was that security issues. Now, a lot of services are developed, and security is now advantage of a cloud. Basically, a lot of systems are transferring their infrastructure to cloud just to increase their security. How we use it? Basically, we send authorization signature to the Cognito using public and private keys. And then Cognito returns the tokens. And using those tokens, we can approach resources on cloud. Basically, you get ID token, access token, and refresh token. And then you are defined as a client. For example, you have horizontal authorization and vertical. So you can approach these resources. And also, you can on these resources, you can perform some operations like create, delete, or something like that. So basically, this service enables us to control who can do what on our AWS. Simple queue service. This is basically a simple queue that enables decoupled applications to communicate. Some applications send message, and we have listeners, and then some other applications are waiting for that message and pick up from that queue. It will be much more clarified using this diagram. I will explain it our system. So basically, what was our client idea? They have some internal information system, and on the other hand, they have a lot of devices, like more than 10,000 devices, and they want to connect those two. They want to collect the data from this side here, and how we did it? We put AWS between those two entities. And just to show you how it works, for example, from this side, a request is sent on API Gateway with the authorization token that it can use AWS services, and then, for example, create user. We send that request to API Gateway, and then that request triggers code execution on Lambda. Basically, Lambda writes something into DynamoDB or triggers some other Lambda. That other Lambda also can write something into DynamoDB. And also, it can send some message on the queue where this service waiting for this message to appear. In the same time, it can, we don't see all the line, but it can upload some file to S3 bucket. S3 bucket also can invoke some other Lambda. Also, it can be from other way around. This service sends some message to the queue, then Lambda is invoked through the API gateway. Some notification is sent to device. This is also some external system that can upload files to S3 bucket. Basically, for example, we use software updates. New software is released, then package is uploaded to S3 bucket, and then Lambda is invoked, something is written in database, some notifications are sent to device. So, how I can monitor stuff that's going on? Sorry. How we can monitor stuff on AWS? Basically, I start with AWS Toolkit for Visual Studio. I use Visual Studio in my everyday work, so it was really convenient. And after a while, I realized that there are some restrictions regarding that toolkit because, for example, I couldn't see the objects in database. I could see only simple values, like strings and integer and stuff like that. Then I switched to AWS console. And basically, it's a web application. You can approach it through the browser. And you can monitor a lot of stuff using this CloudWatch. It's a service that comes by default. So you don't have to specify, I want to use this service. It comes in every configuration. And as name it says, you can watch what's going on AWS. Basically, you have a lot of logs. So basically, if you want to check something on Lambda, you go on CloudWatch and find that log file and search for it. For example, if I see some problem, something is not expected, I want to create user and user is not created. First point where I go is there on logs and search for error log. Usually it's very intuitive. Just based on that, I can say to my developer, should I create a bug or you just know what's going on? And that's in most cases very intuitive and all investigation stops there. Second way to monitor AWS is to check DynamoDB. Basically, this is like a list of your databases, and this way you can search through records in that database, and that way you can find what you want. But those are no SQL database, and it's basically key-value pairing. So if you have a key, it's very easy to find some record, but if you don't, there are ways, but it's much more expensive and much more complicated. If you want to see what's going on S3 bucket, you can go to that browser application and see like those buckets contains folders, subfolders, files. So for example, if some file needs to be created, you just go there and check if that is created. So how I wrote my test cases for my application. It's different than when you have UI. For example, you can say when you fill this form, press this button, and then stuff like that. When you test backend, you don't have that privilege. You need to specify it something like this. So once again, the example of user creation. Create user request to AWS. For that purpose, I used Postman. It's a very great tool for testing REST APIs. Basically, I create a request and send to AWS. Then, create user Lambda is invoked. Basically, what I did here, I go to that log file and check if this Lambda is invoked. After that, I expect that Lambda insert record in DynamoDB. Of course, I went to DynamoDB and check if record is created. Then, that Lambda creates a file on S3 bucket. Of course, you can go to S3 and check if that file is created. In the end, we check if that Lambda sends message to SQS and check in the internal information system if that user is created. Basically, you can do one more thing. You can go to Cognito, check user pool. I forgot to mention that, and check if a new user is created. So I assume by looking at this, you see that a lot of things are repetitive. So we figure out why don't automate stuff like that. I already mentioned we don't have UI, so we don't have UI test automation problems, basically. Then we say, okay, great. Since we use C# and .NET framework, we use XUnit. Basically, it's open source, so it was very suitable. It done the job. And we use also SpecFlow. SpecFlow is a behavior-driven development framework that is much powerful than just for test automation. It has those feature files that can be used as a live documentation, can be used as test cases, can be used as a basically not just technical persons can read those files. Just let me show you one of these files. So this way we can decouple tasks. For example, some non-technical persons can write stuff like this, and then developer can read it and implement it. And also some project managers can define their requirements based like this. And also, if you see here, this test user is written a little bit different than all other text. So it can be a test cases because this is our test data. So this is written in given when then scenario. It is very intuitive. For example, you define here what is your feature, you describe it, and basically use given when then notation. For example, this given part is something like your test preparation, when is your test execution, and then is expected result. So behind each of these lines, we have test methods that is executed when this line is defined here. Now you can see my really test method. Don't focus on coding. So how many of you think that testers need to know how to code? Okay. So yeah, when we start automating these things, they ask me, could you do it? And I was like, of course, I automate a lot of stuff. And I started it. It's not that easy. Then I ask for help of developer, and he creates some helper methods, and now we can write it in much higher quality and much faster than when I do it by myself. But it's very nice way you can implement this. Basically, if you look at this line, for example, user and these characters doesn't already exist. If you see here, user and you see these different characters doesn't already exist. Basically, that's how you map your Gherkin with your code. So it's much more visible here. For example, when I send create user request, then user is created. If you see, they need to match with this. Okay, that's how we map those sentences to those test methods. And basically, one really important thing to say here is if you see here, like services.aws.dynamo. So basically, through your code, you can consume AWS services, and everything that you do in that AWS console, you can also do through your code. So I already mentioned that I send my request using Postman. This is the body of the post method that I want to send. And if you look the code here, I just specified it, okay? Use this JSON file, that is this, to send as a request. Basically, I did the same thing that I did using Postman, I did here using this code. And what is really great about it that your test can be implemented as one of the steps in your continuous integration pipeline. Basically, we used VSTS build server in order to deploy our code. And when some new code is developed, then it's on build server. If build is successful, then run all your tests. And if test all passed, then you can deploy it on any environment you want. So basically, I have around 40 end-to-end tests. And if I do it manually, I would need approximately 20 working hours to do that. This way, we did it in like 10 to 12 minutes. So time saving is really, really, really great. I already mentioned that AWS can scale up and scale down, but we need to think about stuff that are not AWS. Basically, here we have entering point, and here we have exit point, which is not AWS. So requirement for our client was that they want to have like 100 requests in 30 seconds, and the response time should not be larger than 1 second. What I did, I used JMeter. It's very open source and also very easy to learn and easy to use. And then I shoot those 100 requests in 30 seconds and saw my results. What happened? In situation when I need just AWS, so do something and get it back, it was like less than a second. It was no problem. But in situation when we need to go here, check something or retrieve some data from here and go back, that was a really problem, and we had response like 5 seconds, 6 seconds, and it was unacceptable. Also, what we noticed is the behavior of Lambda. Lambda can be cold and can be hot. What that means that if Lambda is not invoked for a very long time, for a couple of days, and you try to execute some code on that, you will need like 10 seconds or more. But if it's hot, if it's used often, the response is like half a second. And what we did, we implement some logic that some dummy requests are sent for every 30 seconds for each Lambda. And that way we keep it warm and basically fast. So I was very fast. I didn't say this fast. But what I want to say that cloud is really here. It's not something that will come in the future. And when you compare the stuff on on-premise solution and on cloud, I realized that it's much more easier to monitor stuff on the cloud, because you have like that's AWS browser stuff, and you can check all in the browser. You don't have to remote on some server. You don't have to know where some database is hosted. You don't have to know where some logging system is hosted. You all do that from one point. You just have to choose your environment. And also, we didn't have UI, as I already mentioned, and we can that's how we can create some automated tests that are robust, that doesn't have those UI automation problems, control not found, and so on and so on. Basically, I have some tests that I wrote like 6 months ago, and without any maintaining, they still work as expected.
There's still time. Are there questions?
Okay.
Hi, I would have a question about locally testing the whole infrastructure. Do you have such case in?
No, we don't have any kind of local, let's say, replica of AWS. Basically, we do that on development environment. So it's very easy to create environment on AWS, but we didn't create some local copy of that.
Yeah, but it comes with some dollars on AWS, yeah?
With some?
With some cash, you have to pay for that infrastructure for testing.
Yeah, all cloud solutions are paid as they're used. So, yeah, if you want to test, for example, load testing, that will increase some costs, but we did it online because the number of our requests is not that.
Do you use containers?
No, I don't think so.
You don't use? Okay, that's all. Thanks.
Thank you.
What was the biggest challenge you encountered during moving to cloud testing, and how you dealt with it?
Well, when I started to work on this project, I thought it is something like really complex and stuff. But when that first period passed, then I realized it's much simpler than before that on-premise solutions. So, besides I don't know, some starting issues with the missing documentation regarding testing, stuff like that. I don't see any bigger issue. It's much easier than stuff that are hosted on premise.
Any more questions? At least two. There's plenty of time.
Hi, I was wondering, because you said that you send dummy requests to Lambdas to keep them warm. You did it for the testing purpose or to speed up the request response?
Yeah, to speed up the response, basically. If you have some features, for example, software update that is not done for like a week or something like that, and then that Lambda which is dedicated for software update is called. Basically, it's not invoked, and we create some logic to just ping it every 30 seconds, just keep it warm, just keep it wake, because how those cloud providers work, if you don't use something, they just shut it down, and when you start using it, they turn it on. And basically that process of dedicating resources to that Lambda and stuff like that lasts for 6 seconds or something like that. And that's why we need to have that logic, not for testing purpose, just to increase the time for response.
So you didn't think about the solution about, let's say, this sometimes expected longer response time for the Lambda cold start. Instead, you because I guess this is kind of a workaround to keep it warm all the time. Yes.
Yeah. Well, workaround that is really acceptable by community. A lot of solutions. We investigate how we can increase the speed of response, and the client was very explicit. I want response less than 1 second. So 5 or 6 seconds were unacceptable, and basically it is kind of a workaround. So.
Okay.
Yeah, that logic will be implemented in production.
There was one more on that side. Is that question still valid?
Why you're using Amazon, not Google Cloud, for example?
Can you please repeat?
Why Amazon, not Google Cloud?
It was an explicit desire of our clients. As I mentioned, Microsoft Azure native language is C#, and we said, okay, we have experience with Azure. Would you like to implement it on Azure? No, they say no, we want explicitly AWS, and it is supported. So
yeah, okay. So the second question: are you able to use JMeter to perform some functional tests? Are you able to use JMeter to get into the pieces of AWS?
No. I only use it here, basically. This is not AWS.
Okay, thank you.
So it's like testing REST API. Yeah.
Maybe ladies first.
Isn't this solution with this request doesn't make solution more expensive? Isn't there another solution to keep it live without additional requests to serve it and
I agree with you totally, but the people who are dedicated to think about costs know that it will increase some costs, and they're fine by it. Once again, as a tester, I told them that, and that's that's what I did. So.
Thanks. I have similar problems in my project. We have, but on Google Cloud. So, yeah, I'm usually just talking. It will be expensive, and they are like, okay.
Yeah, but I'm just not sure with the number of requests. For example, when they talk about those packages on the cloud, they say like million requests and stuff like that. But if we have like, I don't know, 20, 30 lambdas, and it's called like every 30 seconds, well, it's not that much on that big number. So yeah.
Okay, one last question from me. Could you tell the approximate cost of the test infrastructure during tests?
Unfortunately, no. I don't know anything about costs. I know only thing that we have that package and the client is taking care of the cost.
I was just curious, what's the cost of testing on the AWS infrastructure during the whole project? Because
basically you have some those packages like different. That depends on how much you pay for it, but in each package you have some like some stuff that you can use, let's say, by that package. If you go over it, then you pay more.
yeah,
So
on demand.
we never came up to that border when we have to pay more. You know, we have some middle package, I guess.
Yeah, I understand it. Okay, that's all. Thanks.
One additional question: how many testing environment you have?
Currently 3: test, staging, and production.
So who's next?
Regarding this performance, have you measured, because you said once you resolved the issue with performance, there was like about 1 second response time, right? Yeah. Have you measured how much from this 1 second was AWS processing time and what was left for application, in fact? Have you checked that?
No, we just focus on AWS basically.
Okay.
And the response time was really less than half second, depending on how warm Lambda is.
Are there any more questions? If you're shy, drop me a question on Slido.
You sent about this request which is sent every 30 seconds, and I wonder which component sends this request every 30 seconds. It's a separate Lambda in the AWS environment, or you have maybe device outside of AWS?
No, it's Lambda. It's Lambda.
It's Lambda.
Lambda triggered by time, you know.
Okay, thank you.
You're welcome.
Any more questions? Thank you very much, Milovan.
Thank you.